In this video, we're going to practice designing a part in Fusion, then making a print, and then we're going to machine it. It's going to be 3 different videos, or how many ever videos it takes. I think that we'll make a part that is a gland for a mechanical seal. As best as I can remember, I used to work at a place that made them. So here we go. We'll do top version. We're going to call the center. We'll make it 5 inches. Then we'll extrude this cylinder. And we'll make it 1.25 inches. So we have a disc. So now we'll take that disc and we'll cut the inside out with a new sketch on this plane. And I hate when Fusion spins my part, but it does it all the time. So we'll turn off the bodies and we'll go to line, zoom in a little, and we're just going to make an O-ring groove for one side on the ID, and then some undercuts for some packing seals or whatever, or like an inlet outlet groove for a mechanical seal. So here we go. Start there. And it doesn't matter how it looks, we're just making a sketch. We'll come back in and add our dimensions. So there's the lip for the O-ring. I don't remember what that did. Maybe it was a bearing diameter. And that sort of looks like it. Like I said, I don't remember. I didn't design the parts. We machined a bunch of them. I don't remember all the specifics. So we have this ID. Let's give it some dimensions. Let's make this 1/8. Let's make this a 1/2 inch. Let's make our O-ring groove 187, along with a little lip, maybe 1/8, and a backside, maybe 1/8 as well. So it doesn't look bad. Let's make this O-ring squared, 125 by 125, actually 187. That's square enough. Let's take the back to the front of this, make it 1.25. So now let's make our diameters look a little bit better. Let's drag this down. Let's actually make a constraint here. We're going to do a dimension, but we're going to make that dimension the same as this 187. So it calls D9. So now they're tied together. So let's get out of dimensioning. We'll drag it down. They both come down this time. Let's say this is going to be a shaft of 1.5 inches. So 750 bore, which is the radius. And then we'll make this, let's say 2 1/4 that's too big. 2 divided by 2. Alright. I'll make this lip 2.75 divided by 2. And then we'll make this 3/8 deep. It's going to be hard anyway to do with the grooving tools. Alright, so we have our bore here. It's just something I came up with. Some mechanical seals will have it. Again, not an expert, just making it up as I go. Let's take that, we'll turn on our bodies, go to solids, and go to revolve. And it's going to ask us, it already selected the profile, which is what we drew. The axis is going to be the OD, and there that is. Let's spin it a little bit, see how it looks, and we can actually make it a little transparent and see our interior. There it is. Alright, now most glands have a lip on top, which is the same size as, or a little bigger than the O-ring groove. So let's measure what our O-ring groove is. So 750 plus 187. We'll take a new sketch, go to the top, a diameter from center, and we'll put parentheses 750 plus 0.187 close parentheses times 2, and that will give us a diameter. Alright, now we want to extrude this outside part. Man, let's go 250. Okay, now cut. Why? Because that dimension we put in there is the exact size as that major ID in the O-ring groove. So let's add something here. Let's add an 1/8 of an inch. 1.25. Let's actually add a quarter. All right. So there's our gland. It's going to need some bolt holes or some slots. The ones we used to make were slots. So we'll go to the top. We'll put a bolt pattern and then drag out our slots. New sketch. Touch the surface we want. Circle. I'll just kind of put it here in the corner in the first quadrant, and we'll make it a 1/2 inch slot. We want to make it at 45 degrees, so what I do is I just drag a line, I make a triangle, and then dimension it, making a right triangle. The one side has to be 45. The other ones are already in relationship to the plane we were on here in the red. Now we'll take coincident and we'll touch the dot, the center line of the hole, and touch the hypotenuse. Now they're in line. So now we can give that a dimension. And let's go with 1.75. And hopefully it doesn't break into our groove in the ID. We're not done yet. We have to drag out some slots. So we'll touch the line to the OD of that bolt hole. We'll hold shift and drag it out. You'll see a line showing, a circle and a crosshair showing that it is in tangent with the circle. Now you want to drag it out, and when you get a snap there, it's going to show that it's parallel to the 45-degree line there. So you'll click, you'll see a little square there. It shows that it's a 90 as well. And what I like to do is drag it out to wherever, but then when you click there, you're making the connecting. You want to zoom in, and you'll see that circle right there means that it's tangent. So click there. Now this other line here might not be square, so you'll take that and you'll go to perpendicular. You'll touch that line with your exterior line there, and now that's square. So you'll see the perpendicular line there. Grab the other one, do the same thing. Now they're perpendicular. The good thing is you can do the same thing to the center line here that's 45 degrees. And now it shows the over constraint, so that's good. So we'll extrude that and see if we break into the large groove that we had in the ID. So we're going to extrude that through. And I can already see that it broke through. Press OK. And there it is. Alright, so what does that mean? We're going to have to go at least half the diameter, or we'll make the OD bigger as well. Alright, so let's go back. We'll make the OD bigger by, we'll go 6.5. Okay. Then we lost something here. Let's try and get it back. Alright. So our last extrusion was the issue. And we're going to pull this line here out. Press OK. Now that clears us there. Now we're going to also go back in here, make this 2 1/4. Now we are not breaking into our groove. It's probably close. We'll go in here and make it transparent and see what it looks like. This is just for the sake of teaching. You know, if you're an engineer, you need a certain thickness there, that's up to you. I don't care. This is just a teaching video. Okay. We have our slot, but it's useless because we need 4 of them. So we'll go to create and go to pattern, make a circular pattern. And we don't want to do bodies. We want to do faces. And we'll select our faces that we want. For sure, these 2. Rotate around and grab the 3rd one. So 3 faces here. And we want a circular pattern. Now it's asking us to select the axis. Anything that's concentric to the part we're doing. And we want 4. So there's 4. And that's sort of a gland, except it needs like an entrance and exit for liquid to lubricate the seals. So let's make that. What side are we on? Okay, we'll work on this side, right side. Now we don't know where the slot is. Okay, so we can go 1/2 inch. We can go 3/8 up. So we'll take this first. Let's actually make a plane on the outside here. So go to construct, offset plane, which is the main one that's already on top. we'll grab this plane, and we have a 6.5 inch diameter. We'll divide that by 2. That puts us a plane right on the edge of the part here. Now we're making, since it's a circle or a cylinder, you can't really directly make features on it. You have to add a plane to it. So this is how we do that. Now we'll do a new sketch, grab this new plane, and we'll make a hole. I'm going to make a 1/4 inch hole so that it goes through. And it's going to be 3/8 from the bottom here. 375. And then we're going to extrude it all the way through. We'll spin it and see what it looks like here. Alright. That looks pretty good, just for teaching's sake. Now, we'll take that same thing and we'll make it a MPT. Because since this is has piping in it, the piping is connected with MPT. So we'll go to the hole type here. We don't need a chamfer. We'll take a tapped tapered hole, and the bottom can be flat because it's going to go through. It's going to go through anyway. Oh, it'll be flat. You'll use like an ISCAR DR drill. It's got a flat bottom. Okay, so we'll take that and we'll select the hole we want right here. Now it thinks we're doing it on the side, so the problem is something else. Now let's start all over. You want a hole on the construction plane, which is here. Alright, so tapered, flat, here, and now we'll drag it to right on top, which is not really helpful because it's not snapping to anything. So why is it not snapping? We don't have anything for it to snap to. It doesn't recognize the hole there. Let's make a new sketch on that plane, and actually we don't have to do that. Let's go to sketches and we'll turn on that last sketch. It already has a point in the middle. So now we can take that, turn on our plane, and then drag it to that snap point right there. It's still not snapping. That blows. Alright, let's make a new sketch on that plane here. Go to point. It snaps to the axis, so we'll keep it there. We'll make that 3/8. Now, without getting out of the sketch, we'll go to hole and do what we were doing right there. Now it's selected it. So now we'll take that and we'll make that an MPT that is a 3/8. 3/8, right? And everything should be there. Let's make that 400. Yeah, let's make it 625 deep. We'll leave some thread there. So that's your entrance or exit, whichever one, in or out. Usually we used to engrave them with in or out or either side. So there's going to be like a little rotating, almost like a tooth or veined disc in there. It's going to circulate liquid coming in and out. They designed it into the parts. Don't ask me why. But we need to make the other hole here. and we'll make 2 more. Okay, we're going to do a pattern, a circular pattern. We're going to do faces. Let's select the objects we want. We don't want this sketch, so let's turn that off. So we want this hole, the bottom, that. Okay, we have to do one thing change here. Let's not model our threads. And they aren't. Okay. And they look like they are. Don't like that. Kind of a pain when you have to select stuff. Alright, we'll deal with it. Create, pattern, rectangle, or cylinder, circular, faces, here, 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 axis, BLD. So let's see what it gives us. Not everything, alright. Let's zoom in. And for some reason it's not letting us grab that. Again, let's go back to this. And we're going to pause here for a minute and see why my threads are not just an example, instead of they're being modeled instead. Alright. Okay, I think we have it. We'll select that and we'll spin it, and it's giving us equally spaced, and we don't want equally spaced. We want partial, 180, and 3 holes. And let's go with negative 180 because I want that hole on the other side, right there on the top. And we'll press OK. So there go our, what this actually is an inlet outlet hole and then a drain hole. So this is just all from memory. I can take a picture of one that I have that I've made in the past. That is the design. It's sort of like it. I don't have all the specifics they have, but that's the end of the design. Next we'll make a print for it, and then we'll make a program, a CNC program. If you found this video interesting or you learned something, like and subscribe. If you have any comments about anything that I could teach you next, let me know in the comments below. Thanks.